Okay, so today we're going through the day 5 notes. You may notice we skipped day 4. We're just trying to condense it a little bit given the time crunch that we're going to be on. So today we're going to be applying the characteristics of a quadratic function to solve real-world applications. To do that, that's really going to involve us finding the vertex, okay? Remember, our vertex is going to be the highest or lowest points of our parabolas with quadratic equations. We have a few different ways on how we can find that. Given the equation you guys get is going to kind of determine the way, the best way, the most efficient way, I should say, to do it. All of the methods will work, but I'm going to show you what each of them looks like. So this is a little bit of a review because we know how to do it, especially after the day 3 notes that you guys took. So let's get into it, okay? So first one is to identify the vertex through the vertex form, okay? You look at this equation right here. We'll do the notes in blue today. You look at this right here. This looks a lot like our vertex form. We have our h and k values. That is what the vertex is going to look like. Remember, our h value is this one right here. When we write it in our ordered pair, it's going to be the opposite of what shows up there, right? The opposite sign is what I mean by that. So if we've got a positive 3, excuse me, that actually means we have a negative 3 as the x value or the h value in our vertex. All right. The k is the last value. That one, whatever the sign is in the equation, is what you're going to write in your vertex ordered pair. Okay. So to recap, we'll just do a little highlighting here. Okay. This one right here, remember, it's going to be opposite sign. All right, so just some review. Most of you guys probably already know that, but just wanted to reiterate that for you. Okay, so method 2 is to calculate from the standard form. This was what we worked on a lot in our previous day's notes, okay? So remember what we're going to be doing. We're going to be taking our b value, putting that all over 2a, right? So the x value of the vertex is going to be negative b, which is going to be this term right here, over 2 of my a term, which is the first one. Okay? So let's try that. So what it's going to be is x equals, remember it's a negative b, and if it's already a negative 3, we're going to change that to a positive 3. All over 2a, which is going to be 2 times a negative 1/2. All right, that's going to give us 3 over negative 1, which is going to equate to, just simplify, to negative 3. Okay, but we're not done there. So now we've got our x value, which is negative 3, and remember what we need to do now is to find our y value by plugging the x coordinate in. Plug in x coord into f of x. Remember, that's our function notation right there, or really just into our equation to find y. Okay? So what that would look like, we'll try to find y. It's going to be y equals negative 1/2 times negative 3 squared minus 3 times another negative 3, and then minus 11 over 2. We do all that, we're going to end up with the answer of negative 1. Remember, we're going to be squaring this negative 3 first. That's going to be 9. We have a negative half of 9 gets you 4.5. Negative 4.5, I should say. This negative 3 distributed to another negative 3. That's going to give you your positive 9. Sorry, these numbers probably just popped up for you. I just solved it off the camera for a second. Make sure I had it right myself. And then you're going to combine your like terms. I changed this 11/2 into a decimal. So it would be negative 4.5 minus 5.5. Combine your like terms to get a negative 10 plus a positive 9. You're left with a negative 1. So your vertex is going to be negative 3, negative 1. For the graphing calculator method, okay? So notice I included in here, we're going to be discussing this in Zoom. Please do attend the Zoom meeting, whichever one you are attending, whether it's on Wednesday or on Thursday. Do that. Have your graphing calculator ready. We're going to go over this equation exactly and show you how you're going to find that. For the Desmos one, what I've done here is included the URL address to the graph that comes up if you type in this equation. So you won't be able to click on it, but you can copy and paste this link, or this URL, I should say, into the address bar. Go there. You will have the graph popped up. If you want to find the vertex, all you're going to do is tap on the minimum or maximum value, and that will come up with the point. It'll show you what that point of that specific graph is, and if you guys want to, you can add some other equations in, toy around with it, and see how exactly it works if you want to try and type in an equation yourself. That's fine. Sorry I couldn't give you guys a video demonstration of it. I know you guys have some experience on Desmos by now, so hopefully this will work for you. Remember, you can't click on this link. You'll just have to copy and paste it in the address bar, and then you'll see what that graph looks like. Okay? So why find this stuff? Why is the parabola important? This one's a pretty simple answer, okay? And we pretty much just talked about it in that last box, but really what it does is it just determines the minimum or the maximum value. Okay? Now, in a graph that we like, the kinds that we've just been looking at, maybe you might not think that's super important, okay? But the reality is there are reasons to use it. So we're going to use quadratic functions to solve and analyze real-world applications, okay? So let's take a look at this first one. The graph below models the relationship between the ticket price for a concert and expected profits. Okay, so in this case, what does the vertex represent? Okay, so what I'm going to do is I'm going to look at my axes. Here's a ticket price in dollars. Here's my profit from those ticket prices in dollars. The way we're going to interpret this graph is we can see that we start out low with no revenue made, is right, because we're below zero. Okay, but we're going to keep increasing as the ticket price goes up. And eventually we're going to hit a maximum value, right? That's maximum because it opens downward and those arrows are pointing down. And as those ticket prices increase, our profit actually decreases, okay? So in this case, what does the vertex represent? Vertex is going to be our highest point, right? So the vertex represents our maximum profit. Okay. What about the y-intercept? What does the y-intercept represent? Remember, this is where our x value is going to be 0, and our y value is going to be somewhere on the y-axis. We're finding out where it crosses, okay? So I'm going to change the color of this one a little bit. We'll go to green. So actually, we'll get rid of that line. I'll make it green, okay? And that point's going to be somewhere around here. What does it mean? Well, what it means is the profit when 0 tickets are sold. Right? And that point is actually going to be 0, we'll call it, well, it's going to look like 0y. We can't say exactly, but we can tell that our axis is going to be increasing by quite a bit. So let's just stick with 0, y for right now. Okay? What about the zeros? What do the zeros represent? These are going to be your x-intercepts, or where the graph crosses the x-axis. So this equation is going to look like x. Actually, we're going to make that one a different color also. We'll go with red for that one. This is going to be x, 0. Okay? And this is going to be the ticket prices when 0 profit is earned. All right, so when y is 0, x is going to have 2 points there. All right, that's going to be roughly here and here. Okay, so that's what each of those points on that graph would represent. All right, and those are going to be the things that we're looking for when we're doing these real-world situations. Okay, so let's try one. All right, the value of Jennifer's stock portfolio is given by the function v of t equals negative 3t squared plus 73t plus 5, where v is the value of the portfolio in thousands of dollars and t is the time in months. All right, I'm going to go back to my blue color here. So how much does Jennifer start with? So how are we going to figure this out? Okay, so this is going to be considered as time goes on based on this equation, right? Well, when we first start, that's assuming there's 0 time has passed, right? So if t is the time in months, we're trying to figure out how much she has to start. That means 0 months have passed. So let's use 0 for t. So if we're starting out as 0 months, okay, let's just plug in 0 for t. If I did negative 3 times 0 squared plus 73 times 0 plus 5, that's going to equate to 0. That's going to equate to 0. So we have 0 plus 5, so it equals 5. Now remember, v stands for the value of the portfolio in thousands of dollars. That's 5. That means she has 5,000. Zoom in over here so I can write it better. $5,000. Okay. So really all I did there, because I know that with no time passing by, that would be what she's starting out with. I just used 0 for t. Okay. Approximately, when will the value of Jennifer's portfolio be at a maximum? Okay, so maximums are key word right there. Whenever we hear the terms minimum, maximum, think the vertex right away. After I'm starting to think about the vertex, whether it's minimum or maximum, I'm going to see what the situation they've given to me is and how they've given it to me. In this case, they've given us this equation, which is written in standard form. Okay, we know how to find the x value of standard form. Of the vertex of the standard form, I should say. So we're going to do that here. This is going to be that negative b. In this case, it'll be t equals negative b over 2a. Those numbers are going to translate to, we're going to start this work over here, all right? So negative b would be negative 73 over 2a. That's going to be 2 times negative 3. That equals, so this is going to be t equals, whoa. T equals negative 73 over what's going to be a negative 6. That's going to be about 12.1, we'll call it 1.67. I'm currently using Desmos as we do this too to check my answers. Okay, so about 12.167. What does that mean? Okay, so that means about a year, about 12.167 months have passed by. Again, not done yet, because we need to find the value of Jennifer's portfolio, not just at how long has passed. So let's just take the number we just found, plug that into our equation that we've got up here. All right, and then we'll see what our value is, okay? So the value is going to equal negative 3 times, we're going to call it 12.16 squared plus 73 times 12.16, okay, plus 5. Remember, this is represented in thousands. And your answer for that would be, it's going to be a little just about 450, but not quite. It's going to be 450.083. Okay, so remember, this is in thousands, so that's going to be 450.083 thousand dollars. So if we're ever representing this, in the proper form, let's actually just go ahead and do that. I don't want to write it grammatically incorrect. So what I'm just going to do is I'm just going to write it as about $450,000. Okay, so let's try the next one, third one. So what I did for a lot of this, I used the standard form, and I found the vertex from it, and then plugged in our x value from the vertex. In this case, it was our t value from the vertex. What you could also do, and is probably a little bit easier, is to either plug it into your graphing calculator, find the vertex through that, which we'll show you how to do in the Zoom meeting, or type in this equation in Desmos, find the vertex by just clicking on the vertex. In this case, it would be a maximum. And just by clicking on that, you'll get the vertex will pop up for you. Okay, so let's do number 3. For number 3, a t-shirt manufacturer has daily production costs of 0.045 or 45 thousandths x squared minus 110x plus 100,000, where C is the total cost in dollars and x is the number of units produced. What is the production cost for producing 2,000 units? Well, since we're talking about units and x is the number of units, I'm going to find where x is in this equation, substitute x for 2,000. In this case, it's going to look like C of x equals, zoom in here so I can just make it smaller because I already know I wrote it way too big, 0.045 times 2,000 squared minus 110 times 2,000 plus 100,000. All right, you're going to want to plug all that into your calculator, or if you're using Desmos, remember there's different ways you can do this. If you do it on Desmos, you're going to want to find where the x value is 2,000. In this case, I actually think standard form is the best way to do it. So I'll plug all that into my calculator, and you'll get 60,000. 60,000. Okay, so that's going to be 60,000. It is the cost, so it'd be, zoom in here, $60,000. Okay, approximately how many units should be produced each day to yield a minimum production cost? Now remember, we know there is going to be a minimum value because our A is going to be not negative, it's positive. So we know it's going to be opening upwards, yielding a minimum, okay? So approximately how many units should be produced each day to yield a minimum production cost? So because this is just talking about the units, we can find this by just finding the x value of our vertex. In this case, we're going to find that by taking our negative b value, putting it over 2a. Here will be 110 over 2 times 45 thousandths. That answer is, it's going to be 1,222 and 2 repeating. So we'll just call it 1,222. So that's going to be units. Okay, so if I know that 1,222 units is going to be the number of units at our minimum, that's our x, we can plug that number into the equation to find our cost, or our C of x, because remember we need to find a y value as well to answer this question. So you can also do this, like I said, on Desmos. You can use the table setting on Desmos, or you can just click on the minimum value, or you can do the same in the graphing calculator that will show you in your zooms. In this case, I'm just going to plug that unit in. Oops, not going to be 2,000. It's going to be 1,222 squared minus 110 times 1,222 plus 100, plus 100,000. That answer, when you calculate it all out, it's going to be roughly 32,777.78. So this is the minimum production cost. And again, this is all done by just finding your y value of the equation that they give us. Okay, so I know this is, again, a little bit, can seem overwhelming at first if you just stand back and look at the page. There's a lot going on. But there's different ways for you to do it. Whichever one you guys feel most comfortable with is fine. What I've done here is use the standard form because that was the equation they gave us. Utilize the negative b over 2a strategy that you guys worked on yesterday, or whenever we did the day 3 notes, I should say. And doing that's going to give you one of the values of your minimum or maximum. And really, these problems are all about finding that characteristic in the graph. It may be a minimum, it may be a maximum. Either way, we know how to solve for it. And doing so is going to help you find the answers to these. So let me know if you guys have any questions about them. Don't get overwhelmed by it. Any questions we can answer in the Zoom also. We'll see you guys there.